Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 11 video on the chapter of mensuration where I will solve the remaining problems, that is problem number 9 to problem number 13 of exercise 20b. These problems are based on area, perimeter, diagonal of a square and rectangle and a path along a rectangular and area of a path along a rectangular plot. If you have not watched the previous videos on this chapter of mensuration, then I strongly suggest and request that you please also watch them to maintain the continuity of your study on this chapter. If you are so, this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the problem number 9 to 13 of exercise 20b on the chapter of mensuration from the textbook of author RS Aggarwal. Okay, so I have written down all the problems, question number 9 to question number 13 along with the answers. So these problems are all the problems are based on the finding the area of a path along a rectangular plot either inside or outside. Okay. So the first problem, the problem number 9 says that a square lawn is surrounded by a path 2.5 meter wide. So the a square lawn is so the rectangular plot in this problem is a square lawn. It is surrounded by a path, means the path is outside the lawn or the rectangular plot, and the uniform width of the path is 2.5 meter. The area of the path is given to be 165 meter square. Then find the area of the square. Find the area of the square. Okay, let's quickly draw the diagram. So let's say this be the square. Oh, this is a square, so it is a square lawn. Let's say this be the square lawn. Let's say ABCD, ABCD be the square lawn, and there is a path outside. The lawn is surrounded by a path, means the path is outside outside and along the square lawn. So let's say this be the outer boundary of the. I'm very sorry, my diagram will be very approximate. As you can see, the straight lines are not even straight. So let's say this be the outer boundary of the PQRS, the rectangle PQRS. The square PQRS is the outer boundary of the path. So if we consider the width of the path to be x, so these are all x. Since the width of the path is uniform, all this width will be x, and x, where x is given to be 2.5 meter, and so ABCD is the square lawn and PQRS is the outer boundary of the path. Okay, so now find the area of the square. So first we will find, let's say let's say let side length of lawn be let's say a meter. Okay, so what will be the area of path? Now there is a quick formula I have already discussed, that when the path is outside a rectangular plot, the area of the path is x multiplied by perimeter of plot plus 4x square, where x is the width of the path. But unfortunately, you cannot apply this formula directly. you have to solve in a step-by-step way. But in any competitive examination, you can apply this formula that the area of the path, when the path is along a rectangular plot out and it is outside, the area of the path will be x multiplied by perimeter of the plot plus 4x square, where x is the uniform width of the path. So to find the area of the path, you just need the perimeter of the plot. You do not need the length, and you do not need the dimension, the specific dimension of the plot. Only the perimeter of the plot is required. Okay, so area of the path based on this diagram will be area of the rectangle, area of the outer boundary of the path, which is PQRS, rectangle square PQRS, minus area of the square lawn, which is ABCD. Okay, and this will be equal to, what is area of PQRS? PQRS area will be, since the path is uniform, the outer boundary of the path, that is the PQRS, will also be a square, and its side, so we can say this will be PQ square minus the area of ABCD, we can say it is AB square. The side of the square ABCD is AB. Okay, so this is equal to, it is in the form of A square minus B square. So this will be, we can say PQ minus AB multiplied by PQ plus AB. Now what is PQ? As you can see, PQ will be the side, the outer boundary PQRS is also a square, and its side will be A, that is the A, we have small a meter, small a we have considered to be the side length of the square lawn. So this will be A, PQ will be A plus twice x, as we have x on the left hand side and x on the right hand side of the lawn. And so this is PQ, and then we have AB minus AB, AB is minus A. Okay, and again the PQ plus AB, so we have A plus twice x plus A. So this is A cancels out, we have twice x multiplied by twice x plus twice A. Okay, and this is, we can take 2 common from 2x plus 2a, we can take 2 common, and we have 4x multiplied by x plus A. This is okay, so this is equal to 4 multiplied by, how much is 4 multiplied by x, x is 2.5, x is 2.5, and we have 2.5 plus A. This is equal to, the area of the path is given to be 165 meters square, so this must be equal to 165. Okay, so this implies we have then 2.5 plus A will be equal to 165 divided by 4 multiplied by 2.5. This is equal to 4.4 multiplied by 2.5 is 10. So this will be 16.5. Okay, this is 16.5. So this implies A is equal to 16.5 minus 2.5, which is equal to 14. A is equal to 14. Okay, so the side length of the square lawn is 14 meter. So this implies area of lawn is nothing but is equal to area of ABCD, the square ABCD, which is equal to AB square, which is equal to 14 square meter square, and which is equal to 196 meter square. 196 meter square is the area of the square. Okay, let's do the next problem. The length and breadth of a rectangular park are in the ratio 5:2. Okay, a 2.5 meter wide path running all around the outside of the park. The outside of the park has an area of 305 meter square. Find the dimensions of the park. Find the dimensions of the park. That is, we have to find the length and breadth. The ratio of the length and breadth is given. Now, when the area of the path is given, as we know from the formula that the area of the path is x multiplied by perimeter of plot plus 4x square. So, if the area of the path is given and also the uniform width of the path is given, we can easily find the perimeter of plot. Perimeter of the plot. But the problem is that you cannot use this formula directly in your school or in your school exams. In competitive examinations, you can use it. So for school exams, for solving problems in your school, you have to draw the diagram, and you have to find the dimensions step by step. So let's draw the diagram. So in this problem also, the path is running all around outside of the park. So let's say this be the park. So in this case, in this problem, the rectangular plot is the rectangular park. So let's say ABCD is the park. ABCD is the park, and PQRS, this is the outer boundary of the path. So PQRS is the outer boundary of the path, and obviously ABCD is the inner boundary of the path. So we have this is these are all, if I assume the width of the path to be x. So these are all x. These are all x, where the uniform width of the path is given to be 2.5 meter. The width of the path is given to be 2.5 meter. Okay, so we let's find what will be the area of the path. So area of path will be equal to area will be area of PQRS, the rectangle PQRS, or the outer boundary of the path, minus area the park, which is ABCD. Okay, so this is equal to what will be area of the PQRS, the outer boundary of the path. It will be PQ multiplied by QR, minus area of ABCD is AB multiplied by BC. This is equal to, what is PQ? PQ will be okay. So let's say we need to assume the dimension of the rectangular park. So let's say that is, we need to assume the length and breadth of the rectangular park. Now since the ratio is given, so let L is the length of the L and B are used to denote the length and breadth of a rectangular plot. So let L length be 5x, not 5x. I cannot use 5x because I have already used x in the diagram. So let this be, I can use any other variable name. Let's say this be 5t, and breadth be 2t. This is based on the ratio given. It is given that the length and breadth of the rectangular park are in the ratio 5:2. So I can assume length to be 5t and breadth to be 2t. Okay. So now what will be PQ? PQ will be PQ will be 2t plus twice x. And what is QR? QR will be 5t plus twice x minus AB is 2t. So this will be 2t multiplied by 5t. Okay. So this is equal to 10. If you find the product of 2t plus 2x and 5t plus 2x and simplify, it will be 10t square, 10x and 4x, it will be 14x, 14xt and 4x square, and we have 10t square. So 10t square cancels out and we have 14xt plus 4x square. Okay. Okay. So this is equal to, let's take some common out. Let's take out 2x as common and we have 7t plus 2x. So this is the area of the path, which is so this implies we must have 2x multiplied by 7t plus 2x should be equal to the area of the park. The area of the path is given to be 305 meters square. So this must be equal to 305. Okay. So this implies 2 multiplied by the width of the path is 2.5 meter. So 2.5 multiplied by 70 plus 2 multiplied by 2.5 is equal to 305. So this implies 2.5 multiplied by 2 is 5 and we have 70 plus 5 is equal to 305. So this implies 70 plus 5 is equal to 305 divided by 5. This is 61. This is 61. So this implies 70 is equal to 61 minus 5, which is 56. This implies t is equal to 56 by 7, which is equal to 8. So t is 8. Okay. So this implies the length of the park is 5t meter. So this is equal to 5, t is 8, this much meter, or this is equal to 40 meter, and breadth is 2t. Breadth is 2t. So we have 2t meter, which is equal to 2 multiplied by 8 meter, which is 16 meter. So the length is 40 meter and the breadth is 16 meter. Okay. Okay, let's do the next problem. Question number 11, it says a rectangular lawn 70 meter by 50 meter has two roads, each 5 meter wide, running through its middle, one parallel to its length and the other parallel to its breadth. Find the cost of making the roads at rupees 120 per meter square. Okay, there is a rectangular lawn, so let's draw the rectangular lawn. Let's say this be the, let's say ABCD is the rectangular lawn. So we have L, the length is given to be 70 meter and the breadth is given to be 50 meter. And now it has two roads, each 5 meter wide, running through its middle. So, and running through its middle, one parallel to its length and the other parallel to its breadth. So, the road running parallel to the length, uh, running running through its middle. So, the road running through its middle parallel to the length will be somewhat like this. And each and the width of the each of the road is 5 meter. Okay, and so the other road is the other road will be running through the middle of the lawn and parallel to the breadth. So the other road is this road. Okay, so let the roads let name the corners of the road. So let this be EF, GH, and the corners of the other road is I, J, K, L. Now clearly we see that the two roads have a common area, and the common area is the rectangle M N O P. Basically, this is the common area. This is the common area. Okay. So if you have so how do we find the area of the two roads? Area of the two roads. There are many ways, various ways where you can find the area of a shaded. If you have not watched in one of my previous videos, I have discussed how to find the area of shaded region, where the region is composed of multiple two or more rectangles. So in this case also the two roads are rectangles and they are having a common area, that they are having an overlapping area. So okay, now the both the roads are having the same width, so we can say this width is 5 meter and also this width is 5 meter. Okay, now since so the area of the road, the total area of the two roads will be the the sum of the area of the two rectangles, that is the rectangles which are representing the two roads, that is one is EFGH. Okay, so let's say road 1, let's say road 1 is the rectangle EFGH, and let's say road 2 be the rectangle I, K, L and J. Okay, and so the common area, overlapping area is equal, overlapping area is the rectangle MNOP. Okay, so now what will be so area, so we can clearly say that area of two roads, area of the two roads is equal to area of road 1 plus area of road 2 minus, when we are adding the area of road 1 and road 2, the common area is being added twice. So we have to subtract the common area, the area of the common overlapping area once. So minus area of the overlapping area, which is area of I, K, L, J. Okay. Now, what is area of road 1? What is road 1? Road 1 is nothing but the rectangle EFGH plus area. Road 2 is the rectangle IKLJ, and we have minus area I. Sorry, what is road 2? Road 2 is IJKL. Overlapping area is okay. So in the previous step, the minus area will not be IKLJ, but it will be overlapping area is MNOP. So this will be MNOP. So we have minus area. This will be M N rectangle MNOP. Okay. So this is equal to what is area of rectangle EFGH. EFGH, it is EF multiplied by FG plus we have area of IKLJ. Area of the rectangle IKLJ is IJ, that is the width, multiplied by IK, minus area of the rectangle MNOP is MN multiplied by NO. Okay, this is EF multiplied by FG. What is EF? EF is the width of each of the road. So this is 5 multiplied by FG. FG is the length of the lawn, which is 70 plus what is IJ? What is IJ? IJ is also the width of the road, that is 5 multiplied by IK. IK is the breadth of the lawn, which is 50, and we have minus Mn into NO. What is Mn? Mn is basically Mn is a square, because Mn, all the sides of the rectangle or the overlapping area MNOP are the width of the two roads, which are same. So I can say this is 5 multiplied by 5, where 5 meter is the width of the each of the road. Okay, so the unit will be this much meter square. So this is equal to 350 plus 250 minus 25, this much meter square, which is equal to this is equal to 600 minus 25 meter square, which is equal to 575 meter square. 575 meter square is the area of the two roads. So the cost, now we have to compute the cost of making the roads. So the rate of the rate of making the road is given to be rupees 120 per meter square. Okay, so we can say cost of making the roads will be equal to area of roads multiplied by rate of cost of making the road. Okay, so this is rupees. What is the area of the road? Area of the road is 575, and what is the rate of making the road? It is rupees 120 per meter square. So this must be the total cost of making the roads. So this is equal to rupees, how much is 575 multiplied by 12, 10, 11, 5, 7, 5, 0, 12, 9, 6, 6, 9, 2, 0 and 0. 69200 69000. Why? The answer is 69000. Let me see if I have done the calculation correct or not. Uh, 575 multiplied by 12 is 10, 15, 7, okay, 575. Uh, oh, okay. So this will be not 2, but this is 0. This is 0, okay, it is fine. 69000 is the 69,000 is the cost of making the two roads. Okay, let's do the next problem. Question number 12 says a 115-meter long and 64-meter broad lawn has two roads at right angles, one 2-meter wide, running parallel to its length, and the other 2.5-meter wide, running parallel to its breadth. Find the cost of graveling the roads at rupees 60 per meter square. So in this problem, it does not say uh, 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 in the previous problem it said that it was given that the roads are running parallel, the roads are running through the middle of the lawn. But in this problem, no information is given exactly where the roads are running. Only that the two of the two roads, one is running parallel to the length and other is running parallel to the breadth. Okay, so let's say this be the rectangular, so this be the lawn. This is the lawn. Let's say ABCD. ABCD. This problem is very similar to the previous one. The only thing is that in this problem the two roads are having different width. So let's say since it is let's say the road running parallel to the breadth is somewhere here, but the roads are perpendicular to each other, and let's say the road parallel to the length P. This is the road parallel to the length. But one thing we must note that the width of the road, the width of the road which is running parallel to the length is having 2 meter, is 2 meter, and the width of the road which is running parallel to the breadth is 2.5 meter. So, so this so the width of this road will be less. Let's name the roads. Let's say the road parallel running parallel to the length P, E, F, G, and H, and the road running parallel to the breadth B, I, J, K, L, and let the overlapping area between the two roads be M, N, O, P. Okay. So this width is the width of the road running parallel to the length is 2 meter, and the width of the road running parallel to the breadth is 2.5 meter. Okay. So definitely this is the overlapping area, overlapping region, or overlapping rectangle that we need to subtract. So the area, the total area of the two roads will be the area of the two rectangles, that is the rectangles EFGH and the rectangle IKLJ, and then we have to subtract the area of the overlapping region, that is the rectangle MNOP. Okay. So what is L? L is given as 100. L means the length of the lawn is 115 meter and the breadth is given to be 64 meter. Find the cost of graveling the roads at rupees 60 per meter square. Okay, fine. So area of before that, let's just for the sake of discussion and understanding, let's say road 1, road 1 B, the rectangle, the road 1 be the road running parallel to the length, which is E F G H, and road 2 be the road running parallel to the breadth, which is I K L J, and the overlapping overlapping region is the rectangle MNOP. Okay, so now area of two roads will be equal to area of road 1 plus area of road 2 minus area of the overlapping region, that is rectangle MNOP. So this is equal to area. What is road 1? Road 1 is the rectangle EFGH plus area. Road 2 is the rectangle IKLJ and minus area the rectangle MNOP. Okay, so area of EFGH, rectangle EFGH, its area will be EF multiplied by FG plus area of the rectangle IKLJ will be IK multiplied by KL, and the area of rectangle MNOP will be MN multiplied by NO. Okay. What is EF? EF is the width of the road running parallel to the length. So this is 2 multiplied by FG. FG is the length of the road, which is 115, plus IK. IK is the breadth of the road, which is 64, multiplied by KL. KL is the width of the road running parallel to the breadth, which is 2.5 meter, minus MNNO. What is MN? MN is the width of the road running parallel to the length, which is 2, and NO is the width of the road running parallel to the breadth, which is 2.5. So this much meter square. So this is equal to 10 3 230 plus 64 multiplied by 2.5. 64 multiplied by 2.5. 64 multiplied by 25 is 20, 28, 12, which is 0, 10, 6, 1. This is 160 minus 2 multiplied by 2.5 is 5. So this much meter square, which is equal to 230 plus 160 is 390, and we have 385 meter square is the total area of the two roads. Therefore, cost of graveling will be area of roads multiplied by rate per unit area, which will be equal to rupees. Area of the road is 385 multiplied by the rate of making the roads or rate of graveling the roads is rupees 60 per meter square. Remember that the area is also in meter square and the rate of graveling the roads is also rupees 60 per meter square. So this must the rate per meter square must be must match with the unit of the area of the lawn. So this will be 60. This is rupees 0, 30, 1, 2, 3, rupees 23100. Okay. Rupees 23100 will be the cost of graveling the two roads. Okay, let's do the last problem, that is problem number 13. A rectangular field is 50 meter by 40 meter, that is the length is 50 meter and the breadth is 40 meter. It has two roads through its center running parallel to its sides. Okay, the width of the longer road and shorter roads are 2 meter. The width of the longer road means the road which is running parallel to the length. Okay, so let's draw the let this be the rectangular field A, P, C, D is the rectangular field. So the length of the field is given to be 50 meter and the breadth is given to be 40 meter. Okay. ABCD is the rectangular field, so it has two roads through its center running parallel to its sides. Okay, the width of the longer road. Now, width of the longer road means the road which is running parallel to the length. So let's say this be the road running parallel to the length and running through the center of the field. Let this road be E F G H is the road running parallel to the length, and the width of this road is given to be 2 meter, and the width of the shorter road means the road which is running parallel to the breadth is 2.5. Okay, so let this be the road running parallel to the breadth. So let this road be E F G H I J K L. So this the width of this road is 2.5 meter. So obviously this is the common area, common region common to both the roads, or the overlapping region between the two roads. Find the area of the roads and the area of the remaining portion of the field. Okay, so we have to find the area of the two roads and the area of the remaining portion of the field. So what is the remaining portion of the field? Okay, so let's name the overlapping rectangle. So let's say this be M N O. MNOP, rectangle MNOP is the overlapping area between the two roads. Okay, so okay, so let's say road 1 be the road running parallel to the length. So this is the rectangle EFGH. Let road 2 be the other road, that is IKLJ. So the common area or the overlapping region is the rectangle MNOP. And also note that what are the remaining portion of the field. The remaining portion remaining portion will be, we have to find the area of the remaining portion of the field. Now, what is the remaining portion of the field? The remaining portion of the field are the rectangles A, E, M, I, uh, plus um, plus if the rectangle F, B, K, N, plus the rectangle O, L, C, G, plus the rectangle J, P, H, D. That is the four squares, the four rectangles that you can see on the four corners of the rectangular field are the remaining portion of the field. Okay. Uh, okay. So let's first find the area of the roads, area of the two roads. So area of two roads is equal to area of road 1 plus area of road 2 minus area of the of the overlapping area, which is the rectangle MNOP. This is equal to area. This is equal to area. What is road 1? This is the rectangle EFGH plus area. What is the road 2? It is the rectangle IKLJ, and we have minus area MNOP. Okay. So what is the area of a rectangle EFGH? It is EF multiplied by GH. And what is the area of rectangle IKLJ? It is IK multiplied by KL. And minus area of MNOP is MN multiplied by NO. Okay. This is equal to EF is 2 meter, GH is the area of rectangle GH is EF multiplied by not GH but FG. This is FG, and FG is the length of the lawn, which is 50, plus IK multiplied by KL. IK is the breadth of the lawn, which is 40, multiplied by KL. KL is the width of the road running parallel to the breadth, which is 2.5, minus this will be Mn is 2 multiplied by 2.5. So this is equal to 100 plus 100 plus 100 minus 5. This is equal to so this will be this much meter square. This is this much meter square. This is equal to 195 meter square is the area of the two roads. Okay. Now, what will be the area of the remaining portion? As you can see, the area of the remaining portion is the area of the rectangles AEMI, FBKN, OLCG, and JPHD. But also, you can see area. We can clearly say that area of remaining portion will be we can say area of the lawn, that is the whole rectangular lawn, minus area of roads, area of the two roads. So we have the rectangular lawn, we have the rectangular field. Sorry, this is not lawn, but this is field. This is field, area of the field, the two roads. So inside the rectangular field, we are having two roads crossing. They are running parallel to the length and breadth. And so definitely the remaining portion of the field will be the area of the remaining portion of the field will be nothing but the area of the whole field minus the area of the two roads. So what is the area of the field? It is L into B, that is 50 multiplied by 40. And the area of the road we already know is 195. So this is this much meter square. So this is equal to 2,000 minus 195 meter square, and this is equal to this will be equal to 5081 1805 meter square is the area of the remaining portion of the field. Okay, so this was problems 9 to 13. These problems were based on path along a rectangular field, either outside or inside. The remaining problems, that is problems 14, 15 and 16, will be based on how to find the area of a given shaded region, which I will solve in the next video. I hope this video solving these problems will give you a good insight of how to solve this kind of problem. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the remaining problems, that is problems 14, 15 and 16. Let me quickly check how many problems are left. In the exercise 20B, so this is exercise 20B, how many problems are left? We have 14, 15 and 16. 3 more problems based on the area of shaded region, where the region are formed of rectangular or square figures. I will solve that in the next video. So I will end the video here. Thanks for watching, and until the next video, take care and bye.